Could rocket launches be quietly contributing to our planet's changing climate in ways we don't fully understand yet? As space tourism and satellite deployment increase, scientists are beginning to closely examine the environmental cost of every rocket launch. Rocket engines burn different types of fuels, some of which release large quantities of black carbon or soot into the stratosphere. Black carbon particles can absorb sunlight and trap heat, potentially warming parts of the atmosphere more than greenhouse gases. Unlike airplane emissions, rocket emissions are injected directly into the upper atmosphere, where they can linger for years. This persistence allows rocket exhaust particles to interact with atmospheric chemistry far longer than surface-level pollution does. The stratosphere is where the ozone layer resides, and some rocket emissions contain chemicals that may degrade this protective shield. When rockets puncture the atmosphere, they release water vapor and alumina particles that affect cloud formation and radiation balance. The more rockets we launch, the more we introduce these foreign particles into delicate atmospheric systems that regulate Earth's temperature. Reusable rockets like SpaceX's Falcon 9 help reduce hardware waste, but they still emit pollutants during every flight. Solid rocket motors, often used in smaller or military applications, emit significantly more aluminum oxide and chlorine-based compounds. These emissions can form persistent contrails and even participate in reactions that destroy ozone molecules high in the atmosphere. Increased ultraviolet radiation from ozone depletion has downstream effects on ecosystems, agriculture, and animal health. Satellites and probes serve critical roles in communication, defense, and weather tracking, but their launches leave environmental footprints. NASA, ESA, and NOAA are studying how rocket emissions influence cloud formation and stratospheric circulation over time. Some researchers believe that frequent launches could alter global wind patterns and precipitation cycles in the long term. Current launch rates are still low compared to aircraft, but the impact per launch is disproportionately high. As more private companies enter the space race, there's a risk that climate oversight may fall behind innovation. Rockets often launch near the equator to take advantage of Earth's rotational speed, concentrating emissions over biodiverse regions. The cumulative effect of these localized emissions could threaten sensitive ecosystems in the tropics and subtropics. Rocket emissions also include carbon dioxide, but the bigger concern is their release of short-lived climate forces. Short-lived climate forces like black carbon have an outsized warming effect relative to their presence in the atmosphere. The soot from kerosene-based fuels can warm the stratosphere while simultaneously cooling surface temperatures through radiative imbalance. This vertical heat redistribution has unpredictable consequences for jet streams and weather extremes. Space tourism flights, while brief, burn immense fuel for a few minutes of suborbital experience. Each tourist rocket flight emits as much carbon as several long-haul flights per passenger. Virgin Galactic and Blue Origin have pledged to monitor their environmental impact, but regulation is still minimal. Global rocket launch frequency has more than doubled in the last decade, and it's expected to keep rising. Microsatellite constellations like Starlink require thousands of launches to maintain coverage, compounding the emission problem. Even deorbiting satellites burn up in the atmosphere, releasing vaporized metals and carbon into sensitive layers. NASA's 2022 study concluded that soot from rocket launches could warm the stratosphere by up to 1 degree Celsius. This degree of warming at high altitudes can delay ozone recovery and change how solar energy is distributed. Ironically, many satellites monitoring Earth's climate may be contributing to the problem they're trying to measure. Not all rockets are created equal. Liquid hydrogen fuels used by some emit only water vapor. But even water vapor becomes problematic in the stratosphere, where it can increase cloud cover and affect temperature regulation. Rockets launching from sea platforms may avoid urban fallout, but still disturb marine ecosystems through noise and pollution. Marine animals like whales and dolphins are sensitive to the sonic booms caused by launch acoustics. Falling rocket stages can release residual fuel into oceans, affecting coral reefs and plankton populations near splashdown zones. Alumina particles from solid rocket fuels act as nuclei for polar stratospheric clouds, which accelerate ozone loss. Some researchers warn that current rocket designs ignore environmental feedback loops in atmospheric models. If black carbon continues accumulating in the stratosphere, it may outpace efforts to curb ground-level emissions. Environmentalists are calling for a space industry sustainability framework that includes rocket emission caps. Proposals include cleaner fuels, launch taxes, and stratospheric impact assessments before commercial missions. Rocket companies are starting to experiment with biofuels and methane-based engines to lower soot production. Blue Origin's B-4 engine and SpaceX's Raptor both use liquid methane, which burns cleaner than traditional rocket fuels. Still, methane is a potent greenhouse gas if leaked during storage or fueling procedures. Spaceports are being built in previously undeveloped regions, raising concerns about habitat loss and pollution in untouched ecosystems. Wildlife near launch sites may suffer from chronic noise stress, vibrations, and chemical exposure. Rocket exhaust plumes can even trigger lightning strikes that affect local atmospheric electrical fields. Environmental impact reports for launches often focus on local pollution, but ignore stratospheric chemistry entirely. Some scientists propose launching during specific seasons or weather conditions to reduce high-altitude emission effects. Polar launches, while necessary for certain orbits, deposit emissions in areas already vulnerable to ozone thinning. Aurora activity near the poles can interact with rocket-induced particles, amplifying atmospheric chemical reactions. Even paint and insulation from rockets contribute trace chemicals when ablated during ascent or re-entry. The full impact of these trace materials is still unknown, but early models suggest they're not negligible. Rocket emissions may also play a role in the recent rise of stratospheric aerosols observed in climate studies. These aerosols affect how much sunlight Earth reflects and how much heat gets trapped in the atmosphere. Wildlife dependent on narrow climate zones, such as mountain or Arctic species, may feel the earliest impacts. Changes in upper atmosphere chemistry can cascade downward, altering weather patterns and habitat suitability. Some experts worry that if spaceports are built in remote conservation areas, we could lose biodiversity before discovering it. Monitoring rocket emissions is challenging because they occur high above traditional weather and pollution sensors. NASA and ESA are investing in balloon and satellite-based sensors to track post-launch atmospheric changes. The data collected could help refine climate models and guide future space policy towards sustainability. The rise of mega-constellations and frequent resupply missions increases the urgency of understanding these emissions. Rockets are essential for exploring the cosmos, but we must not overlook their cost to Earth's environment. Just as we now regret unchecked fossil fuel use, we may one day question our current launch practices. Balancing space innovation with environmental responsibility is a challenge for governments, scientists, and entrepreneurs alike. By adopting green launch technologies early, the space industry could lead in climate-conscious innovation. Future rocket designs might incorporate scrubbers or deploy emissions-capturing stages to mitigate stratospheric pollution. International space agencies are collaborating to develop global guidelines for emission measurement and reporting. The Intergovernmental Panel on Climate Change has started considering rocket emissions in its long-term climate forecasts. Public pressure could accelerate accountability as more people become aware of these atmospheric consequences. Transparent reporting from companies like SpaceX, Blue Origin, and Virgin Galactic can foster trust and environmental progress. Earth may not be the final frontier, but it's the only home we have to launch from. Without deliberate action, our quest to explore space may sabotage the climate stability we depend on here. While the rocket industry is still small, it's growing fast, and history shows small emissions can snowball into global crises. Reducing emissions early is cheaper and easier than waiting until climate feedback loops are out of control. Scientists stress that proactive measures today can preserve both our skies and our dreams of interstellar travel. Cleaner propulsion systems, smarter regulation, and ongoing research offer hope that spaceflight and climate care can coexist. The challenge is no longer whether we can go to space, but whether we can do so sustainably. Ongoing international cooperation is key to preventing the space race from becoming a race to the bottom environmentally. As we look toward Mars, we must not ignore the fragile blue dot we're launching from. The future of both Earth and space depends on wise decisions made today about how we fuel our journey. Space exploration should inspire awe, not environmental regret, and that means taking rocket emissions seriously now. Policymakers must balance technological ambition with planetary stewardship before emissions outpace regulation. To ignore rocket emissions is to underestimate their unique and potent role in Earth's climate system. The sky is no longer the limit, but what we put into it might determine Earth's future. Every launch has consequences we must consider if we hope to maintain a livable planet. Awareness is the first step. Action must follow before rocket emissions become the climate threat no one expected. Will our pursuit of the stars protect our planet or speed up its warming? That answer depends on how responsibly we treat the atmosphere that rockets now call their runway.